Hello, welcome back. So in the concepts wise in the plastic analysis, so we need to understand this moment curvature relationship in the plastic stage as well. Now, if you look into these the strain profile, this is the strain profile here, okay, and this is at the elastic state. So this is the elastic state. This is elastoplastic state. Elastoplastic, that is, some part of the section is still under the elastic stage and some part is going to the plastic state, and this is completely fully plastic stage. Okay, now the section is called as a completely plasticized. Now if you take up the curvature, so what do you mean by curvature? The curvature is nothing but it is 1 by r. That is, if you look here, because of this application of the load, the beam will bend. Okay, this is we call this as an then the theta, and this is the deformation, this is the slope actually. Okay, so this slope is actually related to the curvature, so it is called 1 by r, the curvature of the elastic curve. So this elastic curve slope is nothing but, so this slope, the strain profile slope is called as the curvature. Okay, now 1 by r is actually, which is equals to, so m by I, okay, m by e, m by I is equals to m by I into by I into m by e. So 1 hour, okay, it is m over e. This is the curvature relationship we get, m over e. Okay, so if I want to calculate this curvature, how do I calculate the curvature? The curvature is actually, if I take 1 by r in the some other form, it's actually f by y, okay, into 1 by e, f by y into 1 by e, 1 by r. This is the curvature. So now the curvature at the elastic stage, so this is the curvature, this is the yield stress. Okay, yield stress, the y is nothing but is the corresponding distance from the neutral axis. So at the elastic stage it is a finite. In the elastoplastic stage, the y, this is going to become y. Okay, that is at the nearest fiber which has gone to yielding. So this is y in the elastoplastic stage. But in the plastic stage, this y would become 0. Y would become 0. So now if you substitute here, what happens? Fy divided by e into 0. So this will become, this goes to infinity. 1 over 0 is actually infinity. So this is what we called is an the curvature becomes infinity at the plastic stage. Okay, the curvature becomes infinity at the plastic stage. Now if you go on the loading, it goes on load like this way. Okay, and once whenever like plastic is going to form where the bending moment is actually maximum, because at the plastic stage, this become as an hinge. So hinge means, again, the hinge has the same meaning as we deal with the normal hinge, but this is become the plastic hinge. So it will go for like infinite rotation. So not, it's actually you cannot imagination with the infinite rotation, but here the huge curvature, that's what we talk about an plastic hinge. Okay, so when the section becomes plastic, that is when the section becomes plastic, and if you look into the stress strain curve, now when all the member has been yielded, so the strain the strain in all the fiber is actually in the plastic stage. So here you have very high rotation. Okay, so this is the meaning of plastic hinge. So plastic hinge means what? So if I write, this is actually what I'm talking about. This is F and epsilon. The same thing. We can draw the moment versus the curvature. The moment versus curvature, m theta curve. Okay, or moment versus m theta curve or m phi curve. So this is m and this is actually 1 over r. This is curvature. So what happens here? It actually up to the elastic limit. Okay, up to the elastic limit, it is going to be straight. Okay, and after that, once the beyond the elastic limit, where some fibers will be under plastic stage and some fiber will be under elastic stage, this is going to be somewhat like curvy. This somewhat is going to be curvy, and when all the fiber has reached the their yielding strain. Okay, yielding strain, this is when, this is what we call it as an, now the capacity here, MP. Okay, this is the maximum capacity. So up to this is my my. Okay, the yielding moment or elastic moment, and this is MP. And once the section has reaches, okay, once the section has reaches, so beyond this, the anything if you put in strain, if the rotation, it does not result in increase in capacity of the section. So it is going to just rotate like a normal hinge. What is the normal hinge? Now if you talk about this is here, this is an hinge point. Okay, as soon as you apply the moment, as soon as you apply the load, it is going to bend. So this here, it is free to rotate here, right? But it is not going to offer any resistance. But this is plastic hinge will offer a resistance up to the capacity. The bending moment becomes equal to the plastic capacity of the section. So beyond that, it is just simply is going to rotate like a normal hinge. Okay, so this is the meaning of plastic hinge. Now what is the difference between plastic hinge and normal hinge? The normal hinge, okay, what we refer is does not has any resistance for the moment or the rotation. But plastic hinge is not like that. It is the state of a section where all the fiber has been yielded. Now if you simply put any further loading or if you put any further deformation, they simply deform. They don't offer more resistance, or the resistance which is in exceed, okay, or more than its plastic capacity. So plastic hinge has moment capacity. Plastic hinge has moment capacity. Plastic hinge, okay, has moment capacity up to MP. Up to MP it will offer a resistance, but beyond that, more than MP, so it's just going to act like a normal hinge. Okay, so the section has become plasticized, and the normal hinge, it does not offer any resistance for the rotation. So you have to be clear about what is this moment and curvature relationship. Okay, so moment and curvature relationship, let me repeat it. So up to the elastic limit, it's going to be straight line, and once it crosses the elastic limit, that is where only after extreme fibers has been yielded, so there will be some more fibers which is they will also be getting into the yielding zone, that is in the plastic zone. So that is where we will get a it's a non-linear relationship. And once all the fiber has reached its yield stress, the section has become plastic. That the corresponding capacity is MP, and beyond that, okay, once all the fiber has reached its Fy, okay, so if you load this further, it is simply going to rotate like an hinge. So that's it. Now since no hinge is formed here, it's going to be an circular, the elastic curve is going to be a circular curve. But once the hinge has been formed here, it is also going to act like an hinge. Okay, hinge means what? Like these two members are going to be act sub independently. Okay, once the plastic hinge has been formed, okay, look at this. Once the plastic hinge has been formed, and also even if you remove this loading, okay, since these members already went to the plastic zone, there will only a partial recovery, but they won't come back to its original shape or the original position. So there will be a deformation. This stage, this is what we call it as a mechanism. Mechanism is that one is the failure state of the structure. The structure is what? Structure is a member which will function, okay, of the object, which will function to carry out the objective. Objective is that like what? Keeping the system in configuration and transferring the load to the required point. Okay. Now, if you remove the load, it will come back to its original position. But when you push the section into plastic stage, there's going to be a permanent deformations. Okay, permanent deformation. And once the plastic hinge has been formed, now it is going to just rotate. Okay, behave like a hinge. Where hinge, they are going to, there will be a lot of rotations. So that point, okay, that is what we call as an the collapse has been taken place. That is okay. So if you increase the load in such a way that like the bending moment at this point is more than my plastic capacity of the section, so what will happen? It will just collapses. That is, mechanism will takes place. The structure will convert it into, it transferred into mechanism. So mechanism is another new term here, is another term. We is an opposite word in the structure analysis for the structure. Structure is a member which can function for the objective purpose, but mechanism is the failure of an structure. So here, once the plastic hinge has been formed, this original member, okay, this original member what just straight here, okay, but this was curved here, okay, because it was still under the elastic limit. And once the plastic hinge has been formed, this is going to be in straight lines, okay, because they are free to rotate. They are free to rotate here, and also they are free to rotate here, so they are going to be an straight line. Okay, so that corresponding state, what we call as a mechanism, has been formed. Okay, so for mechanism, this is only I'm taking a simple structure. I will come back to that, like explaining what exactly mechanism is and on. Okay, for this state, okay, for this state. So now even if you remove the loading after the movement has become more than plastic section moment, okay, the being will become a mechanism. Okay, so this is what you need to understand. This is what we mean by the curvature will be infinity. Okay, the curvature at plastic stage will be infinity. So that is, it's too high. It's going to be too high as compared to the curvature at the elastic stage. Okay, so I hope you clear. I hope it's clear. Okay, and you need to give a thought. You need to think about this moment curvature relationship. Is very important to understand in the plastic analysis. Okay, so we'll see you in the next video. Thank you.